This is question 4 in our introduction to Hess's law, and again something similar to a proper leaving cert question. They are not going to have this delta H is equal to question mark. That's something I've put in, but again, to reiterate, we look for what comes after the calculate the, and if there was actual numbers here, then this would not be our top line. So again, the word respectively here for our heats of formation of hydrogen sulfide, sulfur dioxide and water, they are telling you what goes with what. So this is the SO2 and this is the H2O. So we follow our instructions. We write out our top line. So 2H2S plus SO2 goes to 3S plus 2H2O. We are again using just a method whereby we're going from heats of formation. So the arrows that we're going to be drawing are going to be going up to our top line. So we have written our heat of reaction. We write balanced reactants for formation of all elements. We're going to go with the right hand side of the arrow this time. What do I have to form? We could do it from the left. So heat of formation for this would have to be 3S. So sulfur standard state is S. We have 2H2. So hydrogen is H2, so that can stay the same. And on this right hand side, we technically have 2 O's. So oxygen, the standard state for oxygen is O2. If you want to have a check against the left hand side of the equation, you can. I have 2 S's plus 1 S is 3S, so that's that part. I have 2 H2's here, which is that part, and I have an O2 here, which is this part. So my bottom line is written correctly. So we've done point number 2. So we now label a joining up arrow with its enthalpy of formation and its number. So we're going to start up here with the hydrogen sulfide. So my arrow is going to go up. The heat of formation that we're given in the question is for 1 hydrogen sulfide, but I actually have 2. So I have to go 2 by minus 21. We then go for the next one, which is the sulfur dioxide. So again, my arrow is going to go up. The heat of formation we're given is for 1 sulfur dioxide, and there's only 1 sulfur dioxide here. So that is going to be go 1 by minus 297. And then finally, for our heats of formation that we were given, it was water, like so. And it's only 1 water up here, whereas in our top line we have 2 waters, so that's going to be by minus 286. Now, you may ask, why are we ignoring the sulfur? Sulfur is an element. The heat of formation of an element is 0, so we could put 0 in there if you really wanted. So it would be 1 by 0, but we're not ignoring it. Well, we are ignoring it, but it's not going to impact our maths. So the next part that we are going to do is, we've looked up our other components. We're going to use the direction of the arrows to write our Hess's law equation. So this up here is the delta H that we're looking for, and we want to find the arrows that are all going in the same direction as the delta H arrow. So if we look here, these arrows are all going in the same direction. So I'm going to have these 3 components on one side of my Hess's law equation, and this one other arrow is going to be on the other side of the equals line. So we say delta H is equal to, delta H plus 2 by minus 21 plus 1 by minus 297 is equal to 2 by minus 286. To make sure I get my signs right, I am going to solve both of these before we go. So 2 by 21 is 42, and a plus by a minus is minus 42. Here, 1 by minus 297 is 297, but a plus by a minus makes this minus 297, and that is going to be equal to 2 by minus 286. Now we could solve this 2 by minus 286, but again, I'm always afraid of making mistakes, so I like to keep things that I don't need to do, that I can just plug into my calculator as is. Less chance of a mistake. So I wish to put both of these over to this side of the equal sign. To do that, I have to add plus 42 and plus 297 to both sides. And then I plug it all into my calculator, including brackets, and solve. And once I have done that, I should have an enthalpy value of minus 233 kilojoules per mole.